Hey everyone! Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Rui Tam from Appier AI Research. Ray is the lead author of Let Me Speak Freely, a study on the impact of format restrictions on the performance of large language models. I think this is such an interesting paper about measuring the impact that extracting JSON or structured output from large language models with, say, prompting methods, or maybe we have some kind of generate and then cleanup approach, or of course, constraint generation. I think this is such an interesting aspect of AI. It's emerging, all sorts of applications. Ray, thank you so much for joining the podcast.
Yeah, thanks for having me, Connor.
Awesome. So I'd love to just hear the beginning of what led you to sort of maybe appreciating the importance of structured outputs of large language models, and then maybe also what led you to particularly be interested in the different ways of achieving it.
Yeah, so our interest actually started from when we noticed that JSON formats are actually heavily used in a lot of AI frameworks, especially in, I think, your previous episode, as you mentioned, like compound AI something. So all these like agentic framework uses like sort of JSON format to communicate between like each of the workflow steps, right? So but when we were doing like LM's evaluation side, we noticed that researchers are still using like natural language as their go-to format for a lot of things. So it actually gathered us starting to think like, what would happen if like we benchmark these LMs on like JSON formats? So what would happen? And it's like JSON really the go-to format for a lot of these models. Yeah, which paper we actually explore some other formats as well. So yeah, that's actually started the whole thing, and then it ended up into like we found that so it's a bit bad in reasoning, but it's okay in classification sort of results. Yeah.
Awesome. I really want to come back to kind of JSON, XML, and sort of all the different things you can have constraint generation with. I'm really curious, like something that Bob at Weaviate really likes is it's like generative UIs, or you're generating HTML code. So maybe that's one way of constraining the generation. So it's valid HTML code, or you have a domain specific language, or maybe say it's SQL, and or these ideas around generating valid Python code. I think there's so much to that, but yeah, so I really want to dive into the title of the paper. I think you nailed the title of the paper. I think it's something like 80% of the success of the paper is determined by the title. But so let me speak freely. It kind of implies that constrained generation is limiting large language models. Can you maybe dive further into your opinion on that?
Yeah, so when we were like using JSON to benchmark all these LMs, we find that like the more stricter the the generation is. By strict I mean like there's a so-called JSON mode in a lot of like these LM providers. So what they do is that I think they have like some kind of special decoding at behind all of this thing to make sure that we get like higher success rate and JSON generation. So we noticed that like when we limit a lot of these benchmarks results on like this JSON mode, we do get some kind of like degrade and final benchmark scores in a lot of models. Not just like, I think at the time we were using like GD 3.5 Turbo, but we also benchmark on like Gemini, the latest Llama, and the Gemma models as well. And we noticed like it's the same across like all these models. So we think that there's something like definitely something interesting going on here. So yeah, that's then we then just like came up with like some looser decoding, we call it FRI, and also try with like two-step approach where we make sure that so the models aren't like constrained too much at the end. Like make sure it's like more aligned to the natural language side. And we do find that the results are like much better. Yeah, so that's definitely like some interesting findings here.
Yeah, and so I definitely want to come back to the evaluation, and I think you found the results are better with the reasoning data sets, which is the sort of GSM 8K math reasoning data set and things like this. And I'd really like to get your opinion about, say, evaluating more open-ended tasks, like say writing a summary or these kind of things where you use maybe LLM as judge, or you also kind of cross into the domain where evaluation is so complicated. But I really, before we kind of go further into the methodology of evaluating these methods, I want to kind of again unpack the methods further. So you mentioned FRI, format restricting instructions. This is where the prompt says something like only output JSON, or some phrasing of that results in the JSON. And then the natural language to format, that's where I guess you just generate it in an open-ended way, and then the second calls to language model formats it. So even outside of constrained generation and these special decoding methods, I guess I want to know more about what you think about, just getting JSON by or whatever structured output just by prompting. It seems to me like that approach is very promising because the language models are so good at following instructions. And what we had found in our structured RAG research is that no, you can't just tell it to output JSON. It won't do that. But I would imagine that over time it will get better at this and we'll have better prompts. Right now it's just like the all caps, please, important, right? So what are you finding with getting just JSON by prompting to work?
I mean, initially we find it's quite noisy, like, cause when we were exploring like different kind of formats other than JSON and like in XML or YAML, we find that in some models, they actually perform like better than natural language or JSON in some prompts. And then we realized that the reason is that LMs are very sensitive to prompting. So, there's like a lot of prior work to this, so I'm not going to dive deeper into this. And so what we're doing is that we basically just write like 9 different prompts and then just average the results out. So some of my takeaway is that there might be some like better prompts than the initial prompt that you come up with. So definitely you should try like few of the other prompts and see. I think some of the like different kind of writings is certainly going to make your results much better when whether it's like you're parsing the JSON out for like parsing success rate, or whether it's like the final result they're trying to get, like whether it's maybe a summarization quality or something. So definitely just try writing better prompts, I guess. Yeah.
Yeah, that's a huge trend I'm seeing as well, is just ensembling and batch inference. And I think there's all this like inference scaling laws, and then there's like are more agents all you need. And there's some papers I'll link to the description of this video about like you can scale some tasks benefit from this 100 inferences for the same task, take the best one, some not as much. But especially for the structured outputs thing, it sounds like if you have 10 different prompts, and then, well, so then I guess my question to you is what do you think about this kind of diversity in ensemble? Should ensemble inference, should it just be like temperature set to 0.7, or highest randomness, and then just the same prompt sampled 10 times, or do you think it should be a different prompt 10 times?
Yeah. In my experience, like if you have the choice to choose a better model, definitely go with that, because that will save you a lot of hassle. But if you can't like do it, then maybe try like, as I said, like resampling like 3 times or 10 times until you successfully get a result. In our case, I think like nearly 99% of the cases is that you usually get like a good JSON after like maybe 5 or 10 samples. So this definitely isn't like the integrity of the JSON response is definitely not as of a big issue as we thought it would be, but the final result is what important here. Yeah.
Yeah, super cool. I guess I'm sort of tipping the scales towards the Llama 3.18b instruct, and because of the batch inference. And then I do think once you think about hosting your own model compared to just using the black box APIs, it does kind of unlock a lot of the systems thinking, especially once you're now thinking about compound AI systems. Like you mentioned in the last podcast we had, it was you have like these systems where you have, say, 4 different calls to the large language model. And so just thinking about auto scaling different parts of that, it becomes more intuitive. Yeah. So maybe I just want to know further about, your sentiment on concluding that, say, black box LLMs are still the way to go for building most things?
Yeah, but there's also like I think outlines
Yeah.
which actually support open source models. So we actually tried it out as well, and it is pretty good. Like in ensuring like the success rate of the JSON. So if you are like limiting to like open source models because like privacy or like data issues, then definitely try these tools. We highly recommend it as well. And I think um, the text to generation inference by Hugging Face also supports JSON mode as well. So in our case, we find that like using TGI JSON mode on an older Llama 3 model, ABL model, is like pretty good already. So yeah.
Yeah, super cool. I'm really interested in. I saw Outlines now. They have a company, Text AI, and they just recently had raised a lot of money. And I'm so curious what the future. I think like seeing that kind of investment makes me really excited about what might be next, what kind of structured outputs might be next. And I think yeah, I think that kind of domain specific language thing is an interesting one. Like you could like if it's generating code, is there a way to constrain the generation so it's only possible to generate? I don't really think, I don't know, but yeah. So it's I'm just thinking out loud. I'm very curious about what. Yeah.
Yeah, I think in their latest talk at the I think AI Engineer Summit, like just released on YouTube, I think they mentioned that they were able to get like 100% syntax accurate SQL code using their own inference engine. So definitely for some like simple programming syntax like SQL is definitely doable. But for Python, I wasn't that quite sure, or like
Mhm.
say C or C++, that's like very complicated. So it might be possible, but we weren't sure like whether if like solving it through a data approach, like say train a lot of like valid C++ code or Python code, and maybe that already like achieves like 99.9% syntax correct code already. So yeah, I believe that in the short term, data approach is still like the way to go. Yeah.
Yeah, yeah, that's really cool. I think maybe just quickly to say a little more about. I think the impact of only generating valid SQL code is going to be enormous, especially because of function calling. Like something that we're working on at Weaviate is like our Weaviate agents and trying to interface Weaviate search APIs with this function calling paradigm. And that's pretty easy when it's just searching and you just have the search query or queries string. But now I want to use like the Weaviate's filtered search. And now I need to come up with a domain specific language to select the filters like, greater than 100 and another filter. Or if I want to use the symbolic aggregations like SQL style, Weaviate doesn't quite use the SQL API. We have our own kind of like aggregate API. So the idea that I could come up with some string representation of the language and then the model will only output this thing and follow the function calling, that'll be a huge thing for kind of this like connecting agents with database APIs and more open-ended databases, newer kinds of database. I imagine like Sparkle and Neo4j, like other kinds of things will probably benefit this. Okay, so yeah, I really want to come back to the data approaches and learning to only output JSON. So I'm really curious about the idea of a learned JSON prompt. So maybe it's so I guess there's two camps, like learning with gradient descent or learning with sort of like prompt optimization with like these evolutionary prompt algorithms like OPRO or maybe something like MIPRO, like kind of like the DSPy way of thinking about this, where you have like language model designing prompt for another language model. And so I'm curious if you think that we can design, say, a FRI, a format restricting instruction for all the language models, something that you compile on all sorts of different output formats, like maybe this int task, this composite object string in int task. Yeah, like if you can learn a JSON prompt.
Um, I think it's a term of like where how much resource you want to put into it. So if you have to just like like a day to optimize your whole system, definitely check these prompt optimizer out. Like I think another one is like TextGrad, or I think the SPI also does like similar functions as well. Yeah, but I think it's only like maybe it would only get you like this far. But if you really like deploying to like a million customers, then definitely there's going to be have some like errors where customer is going to complain. So fine tuning might still be needed, but yeah, it definitely depends on like how much resource you could put in, and also like what a scale that you're actually testing on. Yeah.
Interesting. I'd like to take your temperature quickly on the state of fine tuning with gradient descent. I see like there's Unsloth as a new framework. I've sort of gone to the prompt optimization camp with my rationale behind it being it's just so easy to switch out new models, switch between black box and open source models when I'm just thinking about the prompt optimization or the few shot examples. So I'm kind of in that camp of it's either few shot examples or the prompt tuning. But I just want to quickly, understand how you see that.
You mean like how about like using gradient descent method?
Yeah, like the ease of use, how often you find yourself using, generally your sentiment on it.
Yeah, because most of our like daily work still uses like black box models such as OpenAI. So we actually have like access to their fine tuned API service. So I think in like your case, where you guys have like a custom syntax for a lot of like queries and stuff, it's kind of tricky to make it work on a model that haven't seen these kind of syntax before. So and in our case is that when we have like a special domain where it's like quite not familiar by these LMs, we usually have a, a stronger models such as like GB4O for like testing out a lot of generating a lot of like example cases, and then we just simply use these to fine tune the smaller models.
That's awesome. I'm so excited about that. I think that's also we're working at something called generative feedback loops. It's about kind of orchestrating this synthetic data generation, making it sort of like reliable with like a task queue and things like that to generate, say, 100,000 examples with GPT-4 or whatever. To then and then you could do whatever you want with it. But yeah, my experience with the coming back to the Weaviate agents thing in the domain specific language is that I was fine tuning it to generate GraphQL queries, and then after that, that was all it would generate is GraphQL queries. So I lost like the flexibility of it with the gradient descent tuning. So that's kind of something that makes me think that gradient descent tuning for response format it doesn't quite plug you into the agent interface, because in the agent interface, I want it to access these Weaviate APIs, but also I want it to be able to do everything else and maybe use other APIs. So I kind of had said I don't think this is how we're going to achieve that, but awesome. So I really want to now come into sort of back to the paper. Let me speak freely. Coming into the data sets, the methodology, you found a positive result with better result with classification with constraint generation, but you found a better result with the reasoning task with the FRI and all the format, and that thus the let me speak freely. Could you talk more about the evaluation that you did?
Yeah, so most of our evaluations were mainly evolved around two kind of like tasks that people usually encounter in real life, which is like reasoning based, and another one is classification based. So in reasoning, we find that like LMs do perform worse when like restricting on these kind of stricter formats. But in classification based, because there are more aligned to like knowledge intensive, such as like medical, finance, and some sports thing. So in this case is that they typically were using more aligned of like the knowledge that LM already has. So in this case, like um, usually when you're restricting the outputs, it really doesn't matter because it's the same where you're generating like you're doing like 10 more steps or like you just answer it immediately. The results are almost the same. So in this case, it's just up to like how accurate is your final answer. Is this like when we're doing classification, we need the LM to like output. Okay, so we have like 49 choices. You need to output a number from 1 to 49.
Hmm.
And in this case, like JSON mode or like format restrictions would make it very well to restrict the models to output only like these 49 case. And this is where like JSON mode or format restrictions shines, because it literally just limits what the LM can output. Yeah, so in this case, we do find that in this kind of knowledge intensive tests, they do perform better. Yeah.
Yeah, yeah. I thought that was counterintuitive. I would think that maybe like well, I guess I'm just sort of thinking broadly about when like when having it, because it's auto-regressively decoding the tokens, and maybe as it sees it's starting to output JSON, now it's like the distribution alignment. It's kind of like the language model is understanding the task of outputting the JSON better, maybe quicker, compared to the NLDA format where you first generate and the language model might kick it off by saying, "Sure, I can help you with that," and then maybe some JSON or something of that nature. So that's maybe my theory on why this. I like what you're saying about the 49 choices, but for classification, I'm still having a hard time understanding. Yeah, like, what do you think the intuition is for why on classification tasks particularly this is performing better?
Yeah, so I think you mentioned like the possible bias that like the JSON might bring. Um, I think in our final results, we don't see that impact quite a lot as like compared to reasoning. We do like future works to explore much deeper to this thing, like whether does this kind of like bias affects reasoning, and like whether it's like came from like pre-training or fine-tune stage. But for now, we really have like not much of the intuitive like possible why is it not affecting classification tests. We think it's like because of the test that we're using, it's more like lean on testing what the LMs know, and this kind of like knowledge are actually stored inside the LM's weights as well already. So the decoding might not like the decoding domain, like kind of like decoding JSON or XML, the domain that's still decoding might not affect too much on the knowledge is already known. But our benchmark are a bit like limited, I'd say. So maybe there might be like some kind of really niche domain where like it will be affected by, let's say, JSON. Maybe for example, like we see most of these JSONs in GitHub codes, right? So what if like we were actually doing it? We were doing a classification on, let's say, medical, where there are usually their formats are in YAML. So would it be like there is like a subfield of medical that is going to be affected? So far we didn't saw this issue here, but maybe there might have. So that's definitely open for future work.
Super. Yeah, it's kind of. I think that comes back to what we were saying earlier about like. I think more complex structured outputs are on the horizon, in addition to JSON XML and. Sorry, my mind blanked. I just forgot the other one in the paper, but I know there's a third one. I think, right? Yeah, but having like generating valid HTML, valid SQL, maybe that sounds like the next step to me. And then I don't know where this is headed. I guess I don't want to pivot too much. I may come back to the benchmarks, but I did want to ask about what you think about like really complex structured outputs, like it takes one inference and it outputs a lot of things. Like something I've started doing just to like when I start up my language model application just to test the connection is I have it generate a report as a structured output where it first generates the abstract and the introduction, and the related works is like a list of strings, and so I have it just generate like this massive structured output just to kind of like have a laugh at at the structured output API. And so I'm curious what you think have you thought about the applications of structured outputs, just how much this can kind of change the game for AI systems?
Yeah, for I think in our experience is that um, like even the latest models aren't really good in generating like really really complex structural output. And when I think the complexity I'm talking here is like maybe there is like 10 levels of nested objects down. And yeah, and when you're doing like a lot of like complex, when you're like let's say generating a very complex kind of like graph node or something, it definitely starts to degrade a lot in our case. And I think we but we do find that if you initially like start generating a sort of like high level plan in natural language first to like prompt it into like sort of like focus mode, like okay, so this one I'm gonna do, I'm gonna generate like the high level node. It's kind of like whatever values I'm going to do step by steps, and then do the complex like JSON object you want to generate. We do find that like this, we usually use like a much higher success rate through this method. Yeah, but this is like a bit more akin to the two-step approach that we mentioned in our paper. Yeah, so yeah, for complex JSON objects, it's currently still a bit not feasible doing it in one steps, as you have mentioned. Yeah.
Yeah, I think that idea, I've never thought of that before, of having it be unstructured generation, then and then all of a sudden it's turned on. Now it's constrained generation from here on out. That sounds like a pretty interesting idea, and I guess that kind of makes me think about the chain of thought ideas where you have the rationale. Like first, let's think step by step about the task, and maybe that is done open ended, and then maybe it outputs like output start final response, some special token, right, that like that, and then it starts constraint generation from then on. And maybe there's that sounds like a pretty interesting approach. And yeah, I guess generally it's making me think about these more complex chain of thought where we're seeing maybe like tree of thought. I'm not super caught up with this, but if you're trying to structure the reasoning paths, maybe that also is going to be heavily influenced by this defining the schema for what a more complex chain of thought looks. I don't know how you would define like a tree. Like a tree is a structured output, and you're saying like respond to key I like I mod 2.
Yeah, yeah,
So I
yeah.
don't know how. So I'm not sure exactly how that would work, but yeah, I think there's definitely a lot of applications in the reasoning with structure thing.
Yeah,
Yeah.
cause we're actually thinking like, so we're doing like so when we're generating like a very complex let's say JSON output, so basically the model is like switching between two modes. One is that it has to like focus on the structure that the user wanted to generate, and then it has to switch to like, let's say, reasoning mode, where it usually was trained on like papers or like math exchange, where it's mostly in latex, and then you switch back to JSON generating as well. So switching back and forth might be the issue of why it get confused and causing it to like go overboard with like bad JSONs. But yeah, but if we wanted to do like explore this, we might have to do some kind of like internal programming in this. Yeah, which is like out of scope of our paper. So yeah.
Yeah, I think that sounds like quite an intense one to be looking at, say, activations while it's doing. But I do want to ask kind of about future experiments that you might want to do. Yeah, so I'm really curious about kind of, as mentioned, benchmarks that have really complex objects, and then yeah, I guess so. Kind of the purpose of your study is understanding this, like, is constrained generation, is there some big trade off that we're missing out on, right? That we're overlooking when we're adopting these approaches compared to, say, prompting the JSON or having this two-stage kind of generate and then clean it up approach. And so I guess I kind of want to ask about, your opinion on what it would take to extend your benchmarks to really come to this conclusion of saying, definitively structure generation has this huge limitation, or it doesn't.
Yeah, my takeaway is that maybe try it on like a more complex benchmark, such as like plan bench or let's say like multi turn conversations. Yeah, but it's kind of hard to find existing benchmark data sets which we could like really uses the structure to improve the entire experiments. But for right now, I think there's a lot of like agentic benchmark out there. Some were focusing and interacting with like real world tasks to say, please help me book a ticket to, let's say, San Fran. And this usually requires like a lot of like complex step-by-step reasoning in between. Like, you came up with like, okay, so, I have to do maybe search to find like which air ticket should I buy? And then when it's inside the website, it has to do reasoning again. And this kind of like compound reasoning, would it be like worse when we uses let's say structural outputs the entire way, instead of like splitting the reasoning into like natural language and then follow with the structural outputs thereafter? Yeah. If someone wanted to try it out, you definitely try it out themselves. Yeah.
Yeah, again, that's super. I hadn't heard of that idea before this podcast about maybe the rationale or the reflection on the task is unstructured, and then you start constrained. That sounds really like a. I'm definitely excited to try it out. So I'm curious about the history of structured outputs in function calling. Did you like? For me, I actually sort of had totally overlooked this, to be honest. I didn't really pay too much attention to how function calling was limiting it to so if you give the agent four functions and it's going to select one of the function names, you basically have like the enum generation task where you have a
Mm-hmm.
restricted output on does it output one of those four functions. And so did your interest in this area come from you were using it heavily in function call? Like how did you kind of become aware of the progression of work on constraint generation or like structured outputs? So, like, did it start from function calling or?
Yeah, at that time we were really using a lot of, I think there's two kind of structure generation at that time already. One is called JSON mode, and previously most of people were simply using function call. And in our case, we find that like function call does not ensure the ordering of the key and value fields. So when you're doing like reasoning tasks where you need to output your reasoning first and then following by your final answer, usually in function call, it wouldn't adhere to the order that you assign. Let's say, I want reasoning to generate first, and function call might sometimes, it's kind of funky, but it may, first output the final answer and then followed by the reasoning, which you don't want. So for general, like, if the ordering doesn't matter, then definitely you should be fine when using function call. But if the key value, the orders of keys matters, then definitely I would recommend stay away from function call in this case. Yeah.
So that inspires me to think about a lot of things, like kind of the history of, we had Jason Liu came on the podcast, who created Instructor, and that's how I first became aware of the I guess the early days of structured output was you were kind of patching the function calling to do this instead. And so there's something under the hood that I didn't never quite wrap my head around. But this idea that you mentioned of ordering being important, I think that's quite interesting. Like something like I think a lot about RAG and sort of the retrieval augmented generation flow, and maybe something you do is you rewrite the search queries and then you kind of search with them in parallel, and then you have this additional context, or like you're re-ranking the documents, and so you maybe have this order to how you're doing these tasks. I'm not that one. Those two are kind of funky because you sort of have like this interleaved retrieval with the thing, so it's not just like kind of like one generation. But so the best example I've found so far, the ordering really is the chain of thought, where first you want the rationale and then you want the response. Do you have maybe any other examples where preserving the order of the outputs is a huge enabler?
Yeah, another case I think would be it's like when you're generating a stuff like plan to do something.
Yeah.
For example, like if you want LMs to come up with like some kind of like automated workflow generation, then the LMs might like somehow confuse like step 1 and step 10. Maybe you generate step 10 first, but if it is really generate step 10, then it has to somehow make sure that like step 1, 2, 3, 4, 5 actually adheres to what step 10 actually does, which you definitely do not want. Yeah, so I think there's some other examples that I can't really immediately come up with, but this is actually like a really real use case, like workflow generation. Yeah.
Yeah, that's awesome. That's another great nugget I've gotten from our conversation so far. Is I've been seeing a lot of this planning stuff where where I see it mostly in the agent framework where the agent is going to produce a plan rather than just kind of calling the functions iteratively. It makes the plan first, and yeah, so it sounds like a huge enabler. And then I guess I'm a huge fan of this. Well, it kind of comes back to my thing about can it generate valid code? But there's a paper called Meta Agent Search. Sorry, it's called the Automated Design of Agentic Systems, and the algorithm is Meta Agent Search, where you're designing these compound AI systems with the AI model, and so having it follow this kind of like do this, then this, then this kind of syntax sounds really powerful. Yeah, awesome. Right. This has been such an enlightening conversation on Let Me Speak Freely and all these details. So I really want to kind of anchor and discuss just sort of like what future directions, what kind of things in AI excite you the most, like more broadly.
Yeah, I think the next most interesting part will be like test time inference. Like we're seeing like the models released by OpenAI called O1, which usually relies a lot of the we say like chain of thought on steroids. Basically just generate a lot of like reasoning steps during on the fly. And they get like very good results on STEM programming, etc. So definitely keep an eye on this trend as well. So yeah.
Yeah, I think yeah, let me ask you kind of about I see two flavors of this. There's either kind of the ensemble inferences maybe underrated, like just say, again, there could be two approaches to this. It could be you have the temperature set to say zero point 0.8 and you just sample 50 different decodings from the language model, and one of those is going to be better than the others. And then there's the other kind of half of that, which is like maybe it's diverse prompts. So that's kind of one half I see of inference scaling. And then the other half I see is these compound AI systems where you define these like inference flows where you have similar to all the chaining and all this kind of stuff that's been kind of brewing up. But so whereas I think the effectiveness of ensembling inference is maybe more counterintuitive, more. I mean, there are stochastic models, but still, I don't think people realize that this would be the thing. Is that you could just sample the same model 50 times and get the best. Whereas the compound AI system thing, where you're decomposing the task into some pathway where you're sampling a ton of inferences. So yeah, which kind of aspects about it are interesting the most?
Yeah, one analogy that I could think of is that it's similar to like hiring 10 1x engineer versus like hiring a 10x engineer. So currently right now we have like a lot of 1x engineer out there. Like all these models are probably not really like they are going to get better in the future, but currently if they are just like 1x engineer, then it definitely is easier to like um ensemble a team of like 10 1x engineers each, like they're good at each of their tasks. And then it's definitely the quickest way to get your system up to like the max performance right now. But in the future, these models are going to learn pretty fast. So maybe in the short term, they're going to be like 10x engineer and just going to need like one engineers and do all tasks.
Yeah, I guess I've even adopted that kind of model in how I use Cursor, and where I pay the 40 cents to have a one preview tell me what it thinks of the task we're about to do, and then it's back to Cloud Sonnet as we finish the
Yeah.
task. So I think we're even humans adopting that kind of pattern. Ray, thank you so much for joining the Weaviate Podcast. It was such a fun discussion about all these things around constraint generation, getting models to follow these response format instructions, and this inference scaling, and the impact of structured decoding on making plans. I'm definitely excited to check out the plan bench. My interest in seeing structured outputs for plan generation has been improved a lot. Thank you so much.
Yeah, thanks, Connor.